I'm from Michigan State University. This is work I have done with my advisor, Dr. Gillian Tang, and Dr. Yan Li from SNAP. So the title is Toward End-to-End Deception Detection in Videos. These are information about our lab, and also my webpage. Feel free to browse, and if you have a question, you can send me emails. So we know videos are majority of internet traffic is videos. Actually, in 2016, I think 78%, if I'm not wrong, of the whole internet traffic was videos. So huge amounts of data actually is videos that we consume and we send. So from also, internet is kind of a good environment for disseminate of deceptive video. So before going further, I just define deceptive as if a human subject, a video, is not telling the truth, or language is lying or withholding the truth. So verifiably not telling the truth, human subject in a video. So this is, I'm trying to basically make the context clear. So internet is also a good environment because it has a loose regulation and stuff. So this basically motivates us to study this area because it's also is very important. So if we can identify deception in the videos. Besides these, there are countless applications that can immediately use deception detection in videos in practical ways. One of is airport securities. They interview people for security reasons. They delete for terrorism and counter activities and stuff. Job interviews. Unfortunately, some people would lie in job interviews. Yeah, this is skill. Yeah, I know. Those kind of things, which is critical sometimes. Someone who is recruited which shouldn't be recruited and stuff. And last but not least, the courtroom trials. Defendant, someone has been accused with a crime, and there are questions. So, which is very important. If we know that someone is telling the truth or lying, sometimes it's a matter of someone's life or death. So there are lots of other applications like insurance companies and so on and so forth. So, but here we focus, as I will explain the data set, but we focus on real videos from the courtroom trials of subjects, giving a statement about their cases. So, but there are a couple of challenges. The first challenge is, we know videos are intrinsically complicated data. They are multimodal. They have a temporal information reflected in the frames of the video, and also spatial patterns like images and also audios. So, given this is quite unlikely that handcrafted traditional features be effective, and also we expect from deception detection to basically offer an interpretable solution to help both laymen and also experts in the field to boost our understanding of their understanding of deceptions. But given the complexity of the videos, this is also a challenging task. Finally, even though deception is, we said, is widespread, that we have lots of deceptive videos, but number of available data is quite limited. So, and labeling is very time consuming, and is sometimes quite subjective. Is a matter of identifying if someone is not telling the truth is, even for human, is subjective. So given these challenges, we propose this framework. So it has three basic fundamental components. Before getting into component, we have some videos, like human subjects, face visible from front side, are giving some statement, short, like 1 minute, 2 minutes at most. Then we pre-process these videos, separating the video part, audio part, cropping the video is necessary, and we send it to the framework, which has three basic components. One is automated feature extraction, which has two subcomponents itself, and also the visual interpretability. We highlight some of the effect on someone's face. They are related to the deception. And finally, classification module to basically classify them as to trustful or deceptive. So let's go into a little bit detail into these frameworks. The first component is automated feature extraction. So we said we don't want to use any handcrafted features because it would be complicated. So it has two basic subcomponents, one vocal visual feature extraction and visual feature extraction. In each of them, we get like a voice and we discretize it into frames, and each frame, either video or audio, like frame of the voice of someone's picture. We use a convolutional neural network to extract special patterns. So each frame, convolutional neural network extracts special patterns, but we don't have just a single frame, we have a sequence of the frame. For this part, we use LSTM, long short-term memory, which is a variation of recurrent neural network, taking care of the sequential dependencies or temporal correlations. So once we have this, we fuse the features and we send it to classification. So the second component is visual interpretability. This is not an advanced method. We just use on someone's face where the subjects basically we think basically exhibits cues related to deception. So for this we use, if we go back here, we use like, doesn't show here. So in the visual part, we basically use the attention mechanism to highlight which of these frames is more relevant to deception detection. Then we extract out that, and we use some, CNN visualization, techniques to basically visualize what's going on that frame. That's the model I think is most, informative about deception detection. So this is a visual interpretability. Finally, we have a classification module. We mentioned that we don't have that much label data. So for basically to tackle this, not completely, but to some extent this is effective, we use this strategy called large margin nearest neighbor. So in each time we basically take two examples from the same class and another one from the different class. So in this case, we have two trustful videos and one deceptive video. So we get the features extraction as we mentioned before. So we get 3 sets of features, 2 from the same class, 1 from another class. And we basically try to learn the sub-feature that we're in. The samples from the same class are close together, they're pulled together, and that one from the other class is pushed away. So in this, this is taken care of by this loss function you see down there. So, which is enforcing these two should be close together. The first term, and the second term, the other two should be away from the other one. So right now, because we are basically treating all of, we don't have that much label data, yes, but we can produce lots of these triplets, yes. If we think about it, if we have even 100 samples, yeah, from each class, then given that we can have a lot of different combinations of these triplets, so it can be helpful to basically mitigate that data shortage problem. We did some experiments. We utilized a real database of court videos of 6 trustful and 61 deceptive clips. 10 random videos were selected for test and remaining for training. And also we have some basic features that has been shown before. You can find the detail in my paper. So like IS-09, IS-13, some audio features. I used is some facial units, like someone is smiling, someone is groovy, someone is frowning, these kind of things, like 18 features. So here you see the results. So we have in 3 different settings. One is a vocal part. We just use like an audio part. So the def is our model, the certain videos, and visual part and hybrid, which we combine these two. Obviously, we can take away two things from this is both modalities are important, so they are complementary. And also, our model basically is more effective than others. So here is just a simple visualization of one cases of deceptive case. So trustful case, deceptive case, many part of the face, different part of the face has been highlighted, the lip, the nose, but in trustful case, this guy was so calm and didn't change that much. So the model has not basically detected any kind of things, but we need to dig it more to know what's going on with this, because we are not expert in deception detection. We need to basically work with those experts. Okay, why, I don't know, the cheek of someone, the lip would be related to deception. So for future work, we need to basically collect more data, diverse data. That's one thing that we are working on. Definitely more advanced interpretability solutions and approaches is needed. And also there are some basic, deception theories, like from before data, big data and stuff. So we wanted to basically verify if these theories help us, or in which way they can help us. If they can be verified, even some of them by the big data also would be fruitful, basically research. These are references, and thank you so much. Any question? Question.
Yeah, in the back first.
How do you figure out which is a video of someone lying and a video of someone not lying? So how do you acquire your labels for the data?
Oh, that's a good question. So the label has been done in different ways. So these are real videos. Is the court verdicts is one way. So if someone is turned out to be innocent, so they look at it. Okay, this guy was innocent. There was what he was saying. It was correct. So, and also the police report, if this match like the statement, those also is one indicator. There's we haven't collected the data, so I have included the reference, but there's some, it's not just one way to look at, like annotate the data, yeah, there are many ways.
There's directly a question attached to this. Have you listened to the keynote this morning, where they presented the case from the Chinese people, which classified according to picture of someone's bad guy or good guy?
That's an excellent question. That's why we need to collect more data. Basically, we cannot verify those things. Yeah, maybe our model is biased towards females, maybe towards, I don't know, African American, maybe towards some, we don't know yet.
You're not going to solve this with more data.
What?
You're not going to solve this with more videos from justice court.
We don't solve it, but we need to basically even pointing out if the model is wrong, if his model is biased, yeah? At least we need to be diverse in some sense.
No, but I think this is important. I think the lecture in the morning was about a human judgment. So it's about what you think these guys, are they criminal or they are not criminal. However, what Hamid is saying, like the video is telling the truth. And by that, like he is stating that this guy is honest or this guy is a liar. There is a difference between what Google is saying, that we will be closer to the human judgment of who's criminal and who's not criminal, while Hamid is saying we will be closer to the truth. And that's completely two different levels. One saying, based on what people are actually thinking, we have a lot of immediate thinking of the same line. While Hamid is thinking, we get the truth actually. This guy is telling the truth, what has actually happened on this guy. Which is
true, but one thing is what we consider as a truth may not be actually truth. We think it's a truth, yes? So that's a very kind of philosophical question. What is the truth?
So that's why we protect the model community more than bias.
Yes, but the very first thing in not solving the model bias, but showing the model is bias. That's very important. We're showing that should show the model is biased, yes? And which sense is biased, the model is very important. Gender bias, race bias, I don't know, screen bias, whatever.
Yeah, yes.
We should.
I was just saying it's not the model that's biased, it's the data. So
We human are biased.
Saying that the judges are biased, that's the data used to train the models for modeling.
True. So what model? Model is learning from us. We are human, we are biased. So the model is like our kid. So
I would say both. Yeah, there are papers showing that the human model also is biased, tend to learn some latent feature that is unique to communication, and that feature learned may be biased. So it's also possible. But I have a question for you. How do you consider the use of data computation? For example, using GAN or VAE to generate some feature based on the sample we have, so that they can have to learn to shoot first and then
excellent question. So one, it's a little bit difficult because we boil down to how we can generate it. Generating what? We should generate truth and false, yes? So what we consider as a truth and false, we still cannot basically quantify it that much well. So what is it? I really don't have that answer for it. So